Alright, well, if you took the time and figured it out, it looks very similar to our previous problem, only now I have, rather than numbers, x's and tiles and all that kind of fun stuff. So my answer here, then if I were to work this out, just by counting up all the rectangles I created, so this guy here is an x squared, and then I have a bunch of x's. I have 1, 2, 3, 4, 5 x's, so that's plus 5 x's. And then I also have a bunch of ones, 6 of them, plus 6 ones. And so we can use algebra tiles to help us do multiplication and also division of polynomials. So I'm going to show you a couple of examples and let you work on it. So try this one here, see if you can make it work for you. Okay, well, I've intentionally left some of these white because they're negatives. And so go ahead and fill in the rectangles. Remember that when you multiply a negative by a positive, it becomes negative. So go ahead and fill in the squares there and tally them all up and see what you get for an answer. Okay, so the two x squareds are going to be negative because it's a positive times a negative, be negative. And then over here I have negative x times negative 1 is positive x. So I'm going to color that guy in. This will be colored in as well because it's negative times a positive. This is also, oh, sorry, negative times a negative rather. Okay, and then same thing for these two x's on the bottom here. This is a positive 1 times positive x is positive x. So that's colored in, and this is colored in. And then for the singles on the bottom here, I'm going to leave those blank because it's a negative, or sorry, positive times negatives. So then right in here is my solution. So that is I have 2 negative x squared, so negative 2x squared. I have 1, 2, 3, 4, 5 x's, and I have 3 negative 1, so minus 3. Hopefully that's what you got as well. Here's the statement that we write for this. This is on top here, this is 2x minus 3. So 2x minus 3. And over on the left, it's negative x plus 1. So times negative x plus 1. Okay? And what we're actually doing here is something called the distributive property, but we're doing it with binomials instead of just a monomial times a binomial, which is what we did, I think, in grade 9. So the distributive property works the same way, only instead of multiplying, I'm still multiplying what's outside the brackets by what's inside the brackets, but I do it in turn. In other words, I'm going to take the first term here, 2x, multiply it by the negative x. That gives me negative 2x squared. You'll notice the last term here, negative 3 times 1 is a negative 3. The question is, where did this 5x come from? Let's have a look at that with a slightly different example, a bit more easier to work with. Okay, well, I've drawn for you really quickly, really roughly, what the algebra tile representation would be for that. Here's x plus 6 here. This is x plus 2. There's the product here in the middle. But to do without algebra tiles is also going to be required of you, and we do that again using the distributive law. So if you'll notice here, I'm going to take the first letter, the first term here, x, multiply it by the first term in the second set of brackets, pardon me. So x times x is x squared. Multiply x as well by the second term, so x times 2, that gives me 2x. So now I've multiplied the x here by everything in this bracket. I have to do the same thing to the 6 here. So 6 times x, that's 6x, and 6 times 2, that's 12. Okay? And we see the same thing in the diagram. In other words, x squared is right there. I'll use a different color here so it shows a bit better. And then the 2x comes from x times 2. In other words, x times 2. There's my 2x's. And then I do 6 times x. In other words, here's my 6, and here's my x. So there's my 6x's. And then, of course, the 12 comes from right here, 2 times 6. But I can add those two things together, the two middle terms together, because they are like terms, and I get x squared plus 8x plus 12. Okay? And that's how we can multiply polynomials together. So in the next video, I'm going to give you one more example of that, and then as well, one other example a bit more extended. Here we go, one more video.